Hello, folks. I'm going to give you a quick run through about what we're doing today so that you can either fast forward, rewind, pause, whatever you need so that we maximize our time. Uh, to get started with what you're going to learn about today, you should set up your notebook so that you can practice writing these 5 different ionic compounds. So we're going to take their formula and we're going to take their name and write their formula. So when we're looking at how to write the formula from the name, first thing you need to do is find your metal and then your nonmetal. The metal is always going to be written first and the nonmetal is going to be written last. So we know that aluminum is going to be to the left on the periodic table from sulfide, which will be on the right, which is sulfur. So first thing I'm going to do is find aluminum and write what its charge will be. On the periodic table, if you look above it, it'll tell you the charge. So looking at our periodic table, I find aluminum above it is +3 because it's going to lose those 3 valence electrons to become a +3 charge. And for sulfide, it's going to be a -2. Just look it up on the periodic table. So we wrote the symbols, we looked up their charges. Now we've got to crisscross it. What I mean by that is we're going to take the charge and make it the subscript on the ion next to it. So the way that's going to end up looking is we're going to have Al2S3. So that's aluminum sulfide. Let's try potassium oxide. Potassium's +1, oxide's -2. We should get K2O. Gallium chloride. Gallium is a +3. Chloride is a -1. GaCl3. Calcium nitride. Calcium is a +2. Nitride is a -3. And just remember, I'm looking up these charges on the periodic table. It's not magic. I looked them up. So we're going to have calcium 3, nitrogen 2. So Ca3N2 is calcium nitride. And finally, strontium fluoride. Strontium is a +2. Fluoride is a -1. Crisscross them. SrF2. Essentially, all we're doing is just balancing the charges so that the total charge on the atom, the total charge on the molecule will be 0. So I've also got the answers on the next slide for you. This just should let you check your stuff. So now we're going to be looking at the transition elements. So you're going to have to write these down in your notebook so that you can go ahead and write their formulas. Now, writing the formula from the name of transition metals is pretty easy because these numbers here that I'm going to highlight, this tells us what the charge of the metal, remember the metals are written first, tells us what the charge of the metal is. So any metal that's in the D block is a transition metal. So these guys here, you'll notice that there are no charges on your periodic table written above it. That's because they can have variable charges. So we don't have any valence electrons or charges above the transition elements because they can rearrange their electrons so that they can have different charges. That's why we can have iron +1 or +2, lead +2 or +4. And you can't probably see this that well the way I'm projecting it, but this gives you the charges of some of the common transition metals. And you're probably wondering, well, where am I supposed to find that? Well, on your periodic table, I've provided the link for you guys. On your periodic table, you've got the charges of the common transition elements, and I'll highlight it right there. So this tells you all the different charges. So copper can have +2 or +1, iron can have +2 or +3, lead is +2 or +4. So this gives you all the different choices. So let's give this a try. Manganese, oops, let's use something I can write with. Manganese is Mn. We're being told it's got a +2 charge, and it's being bound with nitride, which when we look up on the periodic table is a -3. So this would be Mn3N2. This is manganese 2 nitride. Iron +2 will have a +2 charge. It tells us, oops, it's 3. My bad. It tells us right here. And fluoride is -1. So this will be FeF3 when we crisscross the charges. Chromium 1 phosphide. I think chromium is Cr. Yes. Phosphide. We're being told chromium is +1. If you look up on the periodic table, phosphide, let me show you guys one more time. The phosphide ion will be -3. So we crisscross these charges. Take this, move it down there. Take this, move it down there. And we end up with Cr3P. That's chromium 3 phosphide. And chromium is interesting because hexavalent chromium, I believe it's chromium 6, is extremely toxic. So depending on the valence of some of these transition elements, they can be toxic or they can be non-toxic. So silver 2 iodide, Ag +2, and iodide is a -1. So we're going to crisscross, so it's going to be Ag, which is silver, I2. Nickel 3 selenide, nickel is Ni, its charge is going to be +3. Selenide is Se. What is its charge? I got to look that one up. Selenium has a charge. Where did you go, selenium? Come on, there you go. It has a charge of -2. And if you can't find it and you have this open up as a PDF, you can type in the name and it should highlight it. And I think we determined this was a -2. So we'll have Ni2Se3. And all the answers are on that next slide for you. And finally, these guys. So it's just a random mix of some polyatomic ions. So these polyatomic ions, poly means many. When I lived in Greece, to say thank you very much was efaristo, which meant thank you. Poly. Poly means a lot. So polyatomic ions are ions that have many atoms. And here are some examples of them. And on the back of your periodic table, you've got a list of all these polyatomic ions. They stay together. And it will give you the charge for each one of these. So for hydrogen sulfide, this whole gang has a charge of -1. For iodate, this whole gang has a charge of -1. So you will need to look those up for this one. So we've got beryllium phosphate. So this is our polyatomic ion group. For aluminum hydroxide, this is our polyatomic ion group. For barium nitrite, this is our polyatomic ion group. And for aluminum thiosulfate, that's the polyatomic ion group. Sodium permanganate, that's the polyatomic ion group. And cesium carbonate, that's the polyatomic ion group. So let's write these down first. Beryllium is a +2. Phosphate is PO4 minus 3. The way I found that was I just looked it up. Where'd you go? Let me move this thing here. Phosphate is right there. So it says PO4 minus 3. We're going to crisscross those charges and not break anything up. Don't break the phosphate up. And we're going to write BE3 PO4, and then we need to put parentheses around it to show that we have 2 of those phosphate groups. For aluminum hydroxide, aluminum is +3. Hydroxide, if you look it up, is, where'd you go, hydroxide? It's right here. So it's OH minus 1. We crisscross those charges, we get Al parentheses OH3. For barium nitrate, barium is a +2. Nitrite, we're going to have to look up, has an NO2 minus 1. We're going to crisscross those charges. And that's going to give us barium parentheses nitrite, and put this 2 outside of it. And let's do one more. I'll do sodium permanganate so we don't crowd everything together. So I've got sodium as a +1. Permanganate is a -1, and it's MnO4. We're going to crisscross those charges, and we just get NaMnO4. And in the answers here, I wouldn't put this in brackets actually. We only put things in brackets when we show more than one of a polyatomic ion. So this shows 1 sodium with 1 permanganate bonded together. Whereas over here, this beryllium, we have 3 of those bonded together with 2 of those phosphate groups. And that's what this means. So that means that, let's see, this I'll have a -3, -3. This is +2, +2, +2. And you don't need to write this. This is just so that you guys understand what's going on. So we're going to get 2 electrons from there, 1 electron from there, 1 electron from there, and 2 electrons from there. So that's how they're going to bond. I'm showing the arrows where the electrons are being transferred. That's not something that you have to write for any of these answers. And then finally, you've got some review here for these transition elements, and you also have the answers on the next slide. And with what we've gone over, you should be able to finish these practices and get that homework done. If you have any questions, please feel free to reach out. I'll be standing by during class time. And you guys have a good weekend.